Hello students, welcome to my chemistry class. Today I will discuss about strength of acids. Basically, strength of weak acids. Organic acids are generally weak acids. So we are considering here mainly the organic acids. So suppose an organic acid with the formula HA. So in aqueous solution, HA reacts with water. Water acts as base here due to presence of two low electron pairs on oxygen atom water molecule. So this water molecule takes up the proton from here and the bond breaks and we get the equilibrium H2 plus A minus. You see, the equilibrium, if shifted towards the right, that will be strongest. But if the equilibrium mostly shifted towards the left side, that means the equilibrium is like this. H3 plus A minus. This means that you notice that equilibrium sign, this side is shorter than this side with respect of length. That means the equilibrium is mostly shifted towards the left side. So we see the K, the equilibrium constant of weak acid, K equals to concentration of H3 plus into concentration of A minus divided by concentration of H2 into concentration of HA. Here, as water is present in huge amount, so the change of concentration of water does not change the equilibrium constant. So it actually appears as K equals to concentration of H3 plus into A minus divided by concentration of weak acid. So this is the equilibrium constant for the weak acid, that is K. We are about to use here another term, that is pK. What is pK? pK means minor log definitely base 10 K. Suppose if K is the range of, suppose 10 to the power minus 5, then pK will be for that acid which Ka value is 10 to the power minus 5. So pK equals to minus log to the base 10 of 10 to the power minus 5, that means 5. So K is 10 to the power minus something, whereas pK is a positive value. So to compare the acidity of the weak acids, we generally use the pK value. Where pK value is higher, the acid will be weaker. Larger the pK value, weaker will be the acid, and smaller the pK value, stronger will be the acid. So to compare acidity of an organic acid, what are the factors which affect the, what are the factors affecting the strength of an organic acid. We generally discussed here organic acid. Number one, the strength of the HA bond. If we suppose the acid is HA, the number one factor is the strength of HA bond. Weaker the bond, higher will be its acidity, and stronger the bond, weaker will be the acid. Number two is the electronegativity of A. The electronegativity of A. That means the element which is bonded directly to hydrogen atom. So higher the electronegativity of A, higher with the acid, because A being more electronegative, the electron pair forming the bond, covalent bond, is more drifted towards the A atom compared to hydrogen atom. So higher the electronegativity of A, higher with the acid. Number three is stability of the anion so produced A minus. Okay, and the fourth factor is the solvent factor, the nature of the solvent. The nature of the solvent. So these are the factors which affect the acidity of an organic acid. Of these four factors, A is not normally found to be a limiting factor, but the effect of B is reflected in the fact that the pK of methanol is 16, whereas pK of CH4 is 46. Where? Because here the second factor, if the factor A is very important here, but the factor B is important here, because the oxygen is more, we know oxygen is more electronegative than carbon. Here you see in CH3OH, there is a OH bond, but in CH4 you see all the bonds are CH4. As the electronegativity of oxygen is more than carbon, so in case of methanol, the electron density of OH bond is more shifted towards the oxygen atom, as oxygen is more electron than hydrogen and as well as carbon. But in case of methane, you see carbon is 2.5, whereas hydrogen is 2.1 electronegativity. So there is too much electronegativity difference as the CH bond can be broken. So the pK of CH4 is, we are seeing the pK value. In case of CH4 that is 46, and whereas in case of methanol that is 16. It is obviously the second factor, that means the factor B, the electronegativity factor, arises here more predominantly. So methanol is more acidic than CH4. So if we compare another acid like this, methanoic acid, in case of methanoic acid, you see these are the bonds. Okay, this one is most important here. Okay, so when we dissolve methanoic acid in water, we get the equilibrium HCO minus O minus plus H2O plus. You see here the stability factor, that means the stability of the anion is predominantly affects the acidity of the acid. Why? Because Here you see HCO minus has two resonance structure of equivalent structure here. These are two equivalent resonance structures. So methyloid anion is very stable. Therefore, the equivalence shifted towards right. That's why formic acid, that means methanoic acid or formic acid, is acidic compared to methanol. In case of methanol, you see only one oxygen is present. There are two oxygen atoms, firstly, and after ionization, the produced carboxylate anion is so much stabilized due to resonance. We get the two equivalent resonance structures, two chemical forms. So methyloid anion is stabilized in this way. So the factor C is very important in this case to explain the acidity of methylic acid. So its pKa value is obviously very low, and here its pKa value is 2.77. If we compare the acidity of alcohol with phenol, suppose this is methanol and phenol, so this is phenol. You see, when phenol is dissolved into water, you get phenoxide ion, alright, and H2 plus. But when we dissolve methanol in water, we get H2O minus plus H2O plus. You see, in case of methanol, the CH2O minus has no stability factor because CH3 exerts the plus I effect on oxygen. So negative charge on oxygen is highly destabilized. So this equilibrium is mostly shifted towards the left side. But in the case of phenol, after dissociation, phenoxide ion is generated, and phenoxide ion is resonance stabilized like this, and so on. We get different phenoxide, different resonance structure for phenoxide. Etc. This will be here. Okay. We get the structure and another structure like this. Okay, so we get 1, 2, 3, 4, 5 resonance structures. These resonance structures stabilizes due to the presence of so many resonance structures. They have 5 resonance structures. Thereby, the negative charge on peroxide anion is delocalized throughout the benzene ring and as well as on oxygen atom. So this is delocalized throughout the ring and oxygen atom. So it is very much stabilized. So we get the slight acidity of phenol. That does not mean phenol is very strong acid, but it is also a weak acid, but its acidity still present due to the stability of the phenoxide ion compared to the phenol. Because in phenol we get resonance structure like this. Like this, where oxygen is positively charged and oxygen positive charge, I can here is positive and negative charge separately localized, but in case of phenoxide ion, only negative charge is delocalized. So in resonance structures where the only same type of charge is delocalized, that resonance structures are more stable compared to the resonance structure where both type of positive charge and negative charge, both type of charge are delocalized. So phenoxide ion is more resonance stabilized compared to phenol. So phenol is slightly acidic due to phenoxide ion is more stable than phenol. Okay. But phenol is not much acidic compared to any carboxylic acid. The last factor is the nature of the solvent. You see, in case of when we take the aqueous solution, HCl is very much acidic. But if we dissolve HCl in benzene or toluene, HCl in aqueous solution is highly acidic. It forms H2 plus and Cl minus, and this equilibrium is mostly shifted towards the right, like this. Okay, but HCl in benzene or toluene, it does not dissociate into H plus. HCl in benzene or toluene, that means in organic solvent, does not dissociate, only undissociated in undissociated condition. So HCl is acidic in aqueous solution, but not in benzene or toluene solution. So this is all about the acidity of organic acids we are discussing here. We have already discussed some organic acids and as well as some inorganic acids like HCl, etc. So thank you all for attending my chemistry class. You are always welcome to my YouTube channel to attend my class to learn chemistry easily. Thank you.